question looks interesting. Function is given to you from 1 to infinity to r, and function is given like this. It looks a bit scary. Read the question further. But what you have to do is first try to decode what is this function. If you can graph it, very nice. Okay, you can still answer very nicely. Okay, so let's see the function. So it says that f of t is equal to this when your t is this. What does that mean? T is 2n minus 1. That means t is an odd number. Okay, and what odd number? Okay, that is what is going to decide what's a function. Okay, so you have to start with a 1, you see. So let's draw a real line. Okay, we have to start with a 1. Okay, when do you get a 1? When is t 1? When your n is 1, right? For n is 1, you get t is 1. And then what's the function value? Minus 1 to the power 1 plus 1. That is square, right? So that's 2. So you get f of t to be 2. So let's have it here. Let's have this is y-axis. And you're getting 1 and 2 here. Okay, so 2. Now next odd number, what's happening? You put next odd number. Next odd number you will get when you plug in n is 2. Okay, 4 minus 1, that's 3. Now you plug in negative 1 to the power 2 plus 1, that's 3. Okay, so you get what? Minus 2. Okay, so just have a minus 2 over here. So now can you see, looking at the symmetry, what's happening to the fifth point? Yes, yeah, again 2. Okay, just see, when you are plugging in n is 3, okay, you are again getting a 2. If you are plugging in 4, then you are again getting minus. So you are alternating like this. Okay, 8 also, let me have it. Okay, not 8, 9. Okay, so here you are having like that. Now the other line is telling me what's happening in between two odd numbers. So again, you see, it is depending upon which two odd numbers. So let's take the first one. Okay, t lying between 1 and 3. Okay, so see what's happening, t lying between 2n plus 1. Who is 2n plus 1? This guy, right? So instead of 2n plus 1, I'm going to write a 3 minus t upon 2. What is f of 2n minus 1? That is f of 1. Didn't we say it is 2? Okay, let's write it 2 plus t minus 2n minus 1, which is that lower one. Okay, so 1 upon 2. What is f of 3, right? 2n plus 1 is 3. F of 3 is minus 2. Now this is what you get. Okay, now just simplify quickly. What are you getting? Okay, you are getting 3 minus t plus 1. How much is that? 4 minus 2t. Okay, so your f of t is 4 minus this when your t lies between 1 and 3. Can you quickly draw it again? Yeah, what is when it is 1? Okay, so if you are 1, again you are 2. If you are 3, so 4 minus 2 times 3, that's minus 2. So you are getting a line which is passing through the 2 points which you had earlier. Very 2. Plug in 2 instead of t. If you plug in a 2, you're getting 0. Okay, so this point is 2 in between. Okay, so maybe you, if you want, you can write there. Now one more we need to check between 3 and 5. Okay, and then we will be done with. So what is happening between 3 and 5 to your function? Okay, see, upper odd number minus t upon 2 into the function value at lower odd number, that's minus 2, plus t minus lower odd number, that's 3, upon 2, function value at upper odd number, that's 2. Okay, so I will write 2. How nice, right? Very quick. So 2 gets cancelled, this and this is also getting cancelled. Minus 5 plus t and plus t minus 3. Okay, so you're getting 2t minus 8. Okay, so when your t lies between 3 and 5, it is 2t minus 8. What does that mean? Can you see, again it is this line, okay, which is getting to 0 at 4. Yeah, it is, this point is 4. Okay, now by symmetry you can see that this is the kind of arrangement you are having. This is the kind of function you're having, like this. Okay, this is 6, this is 8, like that. Now rest of the question, g of x. Okay, they're defining g of x is integral 1 to x ft dt. What does that mean? What is this integral tells you? The area, correct? The area from 1 to some point. Okay, so from here you are starting to get the area. To what point they want? They want, see, let alpha denote the number of solutions to the equation g of x is 0. You want the area to be 0. How can the area be 0? When you have equal area on the opposite side, right? So if you integrate up to, let's say, 3, from 1 to 3, if you integrate, do you think that the area is 0? Yes, net area. So when x is 3, it's 0. What more? Even if you integrate this much, still your area is 0 till 5. See, equal and opposite, down, and this is up. Okay, so again you are getting 0 when your x is 5. Again you will be getting to 0 when you are If you take this and you also take this, 7. I can move on, but they're only talking about this interval 1 to 8. Okay, so from 1 to 8, I only get 3 points. So alpha is the number of solutions. So my alpha value is 3. Nice. Let's move. What is beta now? Okay, beta, they are saying its limit x goes to 1 from positive side. G of x. What's g of x? Let's write that. 1 to x ft dt. Okay, that my g of x. Here also it was dt, right? Yeah. Dividing by x plus 1. Now, how do I get this limit? See, number one thing, what you do? You just plug in the value, right? If you plug in x is 1, 1 to 1. What is that integral? 0, right? Here also, if you plug in 1, 1 minus 1, that's 0. 0 by 0 form. What do we do? L'Hopital's rule, our favorite again. X goes to 1 plus. Find the derivative of this integral. Remember? Leibniz rule. What's the derivative of that? Just f of x. Okay, just revise Leibniz rule. Maybe I will put in the information. Okay, and what is the derivative of the denominator? 1. So what is this? F of 1. And what was f of 1? Here, 2. Okay, so f of 1 is 2. Okay, so you got your beta value to be 2, alpha was 3. So what is this? 3 plus 2. So you got a 5. What a beautiful question. See you with another one.